All right, this is Stats Lesson 3 video here. Still looking at differences in shape center and the spread of data, and so we're going to go ahead and get started. You can follow along in your notes. So from this first example, it says your previous work has talked about balance point. And so we have talked about center and mean and median and how that's going to kind of work. But here's the scenario. The kid has a ruler. He tapes a quarter on at 11. He tapes a quarter on at 9. He tapes a quarter on at 1. Okay? And if the pencil was placed under this ruler and we wanted it to balance, if he put that pencil under at 5 inches, do we think it would balance? And so I think that we can kind of tell that based on the 2 quarters over here being far enough out towards the end of the ruler that if I balance this in the middle, there's only 1 quarter over here to kind of counterbalance it. And so this side of the ruler is actually going to be sitting on the table if I were to put a pencil under this at 5. So I don't think that this would balance. No, too much weight on the right side. It is not in balance. Okay, so then as we look at number 2, it said if the ruler did not balance, would you move the pencil to the left or to the right of 5 inches? And so if this is where it did not balance because this side was too heavy, then to me I think we probably better move it this way some. So we would move it to the right. How much? We're not exactly sure, but we're going to investigate that. So for number 3, okay, it says estimate a balance point for the ruler. Let's say that we're gonna estimate, and let's say we need to put it at 8. Okay, so if the position of the quarter is at 1 inch, the distance from the quarter to 8 would be a distance of 7 units, and if I had it at 8, the distance from that, if the quarter was at 9, that would be a 1. And if my quarter was at 11 and I put the balance point at 8, that distance would be 3. Okay? So for number 4 here, it says, what is the sum of the distances to the right of your estimate of the balance point? And so to the right would be 1 plus 3, and that would be a balance point of 4. And number 5 here, what is the sum to the left? Well, there's only one of them, that would be to the left, and that would be 7. And so we're still kind of out of whack here. If we go back and we look at our ruler, if I put my balance point here at 8, it's saying that the total distance from 8 right here is a sum of 4. And if I put it here, then the sum is at 7. And so this time, according to my balance point, this side of my ruler is going to be on the table because it's not still in balance. And so for number 6, it says, do you need to adjust the portion of your the position of your balance point? And so yeah, I would say that we need to move it now a little bit to the left. And here's how I would say that we need to do that. I think that since the difference was 3, so the difference here between to the left, which was 7, and to the right, which was 4. So I know I needed to move it to the left, but the difference there was 3. Now check this out. Because of my balance point, there was 1 coin to the left. Oops, 1 coin to the left. But there were 2 coins to the right. So if I move this 1 inch to the left, okay, this 1 coin on the left changes 1 inch. But the 2 coins that are on the right, they also change by 1 inch each for a total of 3. And And so I know that if I move it from an estimate of 8, if I move it 1 inch to the left to 7, then it will be in balance. So the balance point should be at 7 inches. Because then the total weight is the same from the balance point to any of the coins on either side. Okay, so for number 7, it says calculate the mean and the median of the position of the quarters. So the mean is 1 plus 9 plus 11, which is 21, and I can divide that by 3. And so the mean is 7. The median is just these three numbers, 1, 9, 11, and the middle number. So the median is 9. Okay, it says, does the mean or the median of the positions provide a better estimate of the balance point for the position of 3/4 taped to the ruler? And so we know that the mean is going to be a better answer for us. And that is because it is a balance between the difference of each point of the data. And so I want to kind of draw this out for us on our ruler. Okay, if this is a 1, and here is a 9, and here is an 11, if I put my balance point at 7, I know that this total distance right here is 6. Okay? And this total distance right here is 2. And then from 7 to 11 is 4. And notice that 6 equals 2 plus 4. And that's how we know we're in balance here on our balance point. All right, next example. We're looking here at a junior and a senior class, the total distance walked. We've got 2 different balance points kind of happening. Okay, and
if you are staying for the ball game tonight, you need to be in Mrs. Brotherton's room. If you're staying for the ball game, report to Mrs. Brotherton. Thank you.
Okay, sorry about that interruption. We got 22 students from the junior class, it says, and 26 students from the senior class. And this is a dot plot of each of the distances that they walked to raise money. Okay, so number 8 here, it says estimate the number of miles walked by a junior, mark it with an X. And so we're going to find this mean. Okay, and so if I count these up, I've got 1, and I've got 4, and I've got 6, and I've got 8, just based on the number of dots, and 7, and 24, and 54, and so on. And so when I add those up, I get a total of 155. I'm dividing that by 22 because there's 22 juniors. And so the mean here is going to be 7.04. Just as an estimate, it told me to put an X there. So there's the mean. Number 9 says, what is the median of the junior distribution? So I'm going to go ahead and mark the median. I know that it's 11 from each side because there's 22. So I've got 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11 is my first dot, and if I start from this end, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so the median is going to be right there in between at 8.5. Okay, and number 9, we already did that one, so we can cross that one off. Number 10, is the mean number of miles walked by a junior less than, approximately equal to, or greater than the median? Okay, so the mean is less than the median, and it's because there's a cluster to the left that moves the mean that way. Okay, so there's this lower number of cluster right here that shifts the mean to the left. Okay, number 11. How would you describe a typical number of miles walked by a junior? So for me, I would look up here at my graph, and typical is going to be probably 8 or more. Is typical. Even though we have this group down here, that's not necessarily typical because most of our data is 8 or more. Okay, number 12. It says, estimate the mean number of miles walked by a senior. So we're going to do the same exact thing. In fact, I want you to do this one on your own for seniors. Okay, I want you to hit pause. I want you to go through number 12, 13, and 14. And when you're done with 12, 13, 14, I actually want you to do 16 also. Do those, and when you're ready to see the answers here, go ahead and hit play. All right, so for number 12, when I add these up, I get 178. And this time there's 26 seniors. So I know that the mean here is going to be 6.8, and I will put that X right up here. It's going to be about right there. Okay, and then when I find the median, what I'm doing here is I'm counting from each end, and when I find the median, I end up at 7. So I think I end up here for my first dot and here for my second dot, and I'm at 7. So they're pretty darn close. Number 14, it says, estimate the mean and the median of the miles walked by the seniors. If your estimate of the mean number and miles of miles less than, approximately equal to, or greater than, they're pretty much the same. 6.8 and 7 are pretty darn close. And what we know is that the data is symmetrical. And that's why they're pretty darn close. Okay, so for number 15, it says, how would you describe a typical number of miles walked by a senior? Well, based on our mean and based on our median, we know that around 6 to 7 miles is pretty darn typical. And if you look, 6 is the most, it's the highest part of our graph, and then 7 is next. And so between those two is where most of our seniors are walking. And then for number 16, it says that a junior says that they walked more than a typical senior. Do you agree? And I would say yes. And here's why. Even though they're pretty close, if you compare both the mean and the median for both, juniors are higher. Okay, so I think for the mean it was, for the juniors it was 7.05, and for the seniors it was 6.8, and then for the medians it was 7 and 8, and so the juniors were higher in both regards. Okay, we got just one last example here to look at, and this one is a strange one, so I want to talk about this one just real quick. Okay, so what's different about this is that we don't have any data that is clustered here in the center. So no data in the center. And so we have a big cluster over here around 9 and 10, and then we have a big cluster here around 1 and 2, but nothing really in the center. Okay, so number 18, it says estimate the balance point. Okay, so if we're going to estimate the balance point, we're looking for kind of that place in the middle that's going to be about equidistant from either end of my pieces of data. And so I might say that it would be around 5 to 5.5, somewhere in there. Okay? Number 19, it says, what is the median? Okay, well, as you go through this and you count and you find your median, you're going to see that the median is equal to 2. And so how would you describe the sophomore data distribution? And so here's what we're going to say. For this one, neither the mean, which is the balance point, or the median are good indications here. Because if we use the median, which we found to be 2, it kind of discounts all the data that's up here, even though it's roughly half of the data. Okay? Similarly, if we said that it was around 5 to 5.5 for our average, or our mean, guess what? There are no data pieces that are in that range right there. And so that would be not a great value for us to use to indicate what happened, because actually 0 people walked anywhere between 3 to 8. So to say that, oh, most kids were walking 5.5 is a gross miscalculation, where most of our people were up here at the top or down here at the bottom. And so sometimes our data doesn't really help us at all with mean and median. But in that case, you're going to note that there will be a huge spread, or 2 kind of different bumps in our data, if you will. Okay? So that's lesson 3. When you're done with this, go ahead and get your assignment and let me know what questions you have.